This is part 2 of the Module 11 lecture. In this part, we're going to talk about the regression model and how to estimate the coefficients of the model. All right, in regression models, the dependent variable is called the response variable, and the independent variable x is called the explanatory variable. So be ready, because that's how we're going to talk about a regression model. So the response is the dependent variable. The explanatory variable is the independent variable. A simple regression model means that the model has a single explanatory variable, a single x, and is defined as this. So it's the same model that I showed you at the very beginning, but now we're using capital letters to designate that these are the parameters of the model. So this is the intercept parameter, A. B is the slope parameter. And we have a new term. We have what we call the random error, this epsilon. All right, a multiple regression model, the difference is that it has more than one explanatory variable. And there are many, many types of multiple regression models. Here is one example where I have 3 explanatory variables. So here's A, my intercept. B, 1 is the slope of the first explanatory variable, or the coefficient of the first explanatory variable. B2 is the coefficient of the second explanatory variable, and B3 is the coefficient of the third explanatory variable, or the slope, or the 3 slopes. And epsilon, again, is the random error. All right. One question is, well, what is this random error thing? Well, let's talk about this. So from the perspective of regression, we have a model, and that's, in this case, we're talking about the simple regression model, or sometimes called the straight line model. So this is what we talked about a second ago. So y, again, is the response variable. A is the intercept parameter, so that's where the line intercepts the vertical axis. B is the slope parameter, so this is the rate of rise of the line. X is the explanatory variable, and we have this parameter, the mean of y at a given value of x. So from the perspective of regression analysis, is that if you could fix the x variable at some value, let's say x sub 0, and you measure the corresponding response variable, you will see that this y variable just varies around some average value. That average value is this mu of y given some value of x. And the line, the model that we're fitting, it connects the averages for the distribution of y values for every x value. So that's what the model represents. Now, the random error represents the deviation of an observed value of y from the mean of all the values of y for that value of x. So these random errors is just the random deviations of y from the mean for a given value of x. So this is the perspective that we follow. You may even say the statistical perspective on regression. All right, so with that in mind, then we know, and I was mentioning that these are parameters. If you recall from Module 3, whenever we talk about parameters, well, Modules 3, 5, 6, 7, and 7, every time we talked about a parameter, we were talking about a characteristic of a population. So this is the model based on the population values. So because we don't observe every value in the population, so these parameters A and B are unknown, as well as this mean of y given x, as well as the random errors. We don't know what those quantities are because we don't evaluate every member of the population. And because we rely on a sample from that population, then the actual model that we're fitting based on the data from the sample is what we call the sample regression model. And so this y hat is the response variable, but that's estimating the mean of the y values for a given value of x. Remember, we're calculating the equation of the line. And here, the equation of the line is just predicting the value of the mean. This is very important because this is very important in the interpretation of the coefficients of the model and the predictions of the model. All right, lowercase a is just the estimate of the intercept parameter, and b is the estimate of the slope parameter. But now this is what we call the sample regression model. All right, so now going back to the random errors, these epsilon values, the random deviations of a y value from its mean, are unknown because we don't evaluate every member of the population. But these random errors, these epsilon values, are estimated from the residual values. A residual for a given value of x is just the difference between the observed value minus the value predicted by the model that we fitted to the data. So these are called the residuals, or the errors of, or the fitting errors, as sometimes they're called. All right, so we're going to use these residuals later on, but one thing that you need to remember is that epsilon, the random errors epsilon, are unknown, and we're going to estimate it with these residuals, which is the deviation between the observed value and the value predicted with the sample regression equation. All right, the one question here, of course, is how do we find this value of A and this value of B from the sample data? The way we do this is by minimizing the residual sum of squares. So in other words, what we're trying to do is find a line that minimizes the vertical distances from every observed value to the value on the fitted line. You say, well, how can we do this if we don't know the line? Well, this is a mathematical problem where we replace this y sub I hat by a plus b times x, and then we take the partial derivative of that function, equate that to 0, and we take it with respect to a and then with respect to b. And if you know about calculus, so by equating those derivatives equal to 0, then you find an optimum value. In this case, it becomes the minimal values. Once you obtain those two equations, you resolve them, solve them simultaneously, and then you find the expression to calculate the estimate for the slope and use that slope value and the averages of the values to estimate the intercept. Now, of course, y bar and x bar are just the averages of the y values and the averages of the x values respectively. And these are the equations we learned in Module 3. To calculate the sum of squares, this SS, which designates a sum of squares, is the sum of squares of the x, y values, is we just calculate them this way. Summing the product of the x times y's for every case, minus the sum of all the x's times the sum of all of the y's, and dividing that by n. And the sum of the x, the sum of squares xx, is just calculated in this way. All right. So let's see how we calculate this for the example that we have been working with, where the student wants to find out what the impact on his GPA will be if he starts working 16 hours per week, going from 8 hours per week to 16 hours per week. All right, so we're going to use this data to calculate the estimates of the intercept and the slope. All right, to do this, we need to calculate each of these sums. Once we have these sums, then we can put them into these equations and find all these quantities that we need to calculate these coefficients. So the first step is calculate these sums. And my suggestion is to use Excel to save time. For your homework, use Excel. That way the likelihood of making mistakes is much less, and you're more likely to answer the questions in the Wiley Plus homework correctly. All right, in terms of the exams, I will give you these sums, or I might even give you all these quantities here so that you can just do the last step and calculate the coefficients. All right, in Excel, you can look at this worksheet this is the original data that we were given, and this is the data that you will be given in the homework problem. And you need to extend that table by adding 3 columns and then calculating the product of x times y for all the cells here. And then for the x squared, just square every x value in here. And in here, you just square every y value in here. Once you get those values, sum them up, and you obtain the sum of the x's, the sum of the y, sum of the x times y values, the sum of the squared x squared values, and the sum of the y squared values. Again, go to this worksheet, click on the cells, and you will find the formulas that I use for each calculation. In fact, let me just go there briefly to show you what I'm talking about. So this is the worksheet that is posted on Blackboard. Click on this tab, least squares, and then just click, this is the original data. But if you want to see how I calculated the product, click on it and you see the formula. If you want to see how I calculated the square values, click on it and you see the formula. If you want to see how I calculated the sums, here are the formulas. And you can click on any of this and you will see the sums. If you want to even use Excel to calculate the other coefficients, well, you can click on each of these cells and see the equations that I used. All right. So once you have these quantities, then you plug them into these equations and you calculate the average of y, the y values, the average of the x values, the sum squared of the xy, and the sum squares of the x values. All right, once you have that, then you plug them into this equation, and then you can calculate the slope, which is negative. It makes sense because if you notice the line is pointing down, meaning that as the hours work per week increase, the GPA decreases. So that makes sense that this slope term is negative. Also, the line intercepts at 3.334. So when x is 0, the value will be, or the value of y will be 3.334. So the sample regression line using the intercept and the slope is here. So y hat is equal to 3.334 minus 0.297 times x, where y hat is, of course, the mean GPA for a given number of hours worked per week. All right, so this is how we calculate the estimates of the intercept and the slope using what is called the least squares method, because we minimize the distances from the residuals to the predicted values. All right, in the next recording, we'll get into more details about the regression model and how we interpret the coefficients in the model. In other words, how we interpret the intercept and how we interpret the slope.